Hello, it's Mr. Raps here, and today we're going to talk about rational indices. And rational is just a fancy word for fractions. So fractional indices here. And so if we consider this, we know that if I have like a to the power 5 times, or power 2 times a to the power 5, that gives me a to the power 7. I add exponents when I multiply two things with x. So when I have this scenario, I'm going to multiply a to the half times a to the half. Well, again, that's going to be a to the 1/2 plus 1/2, which is just a to the power 1. But I also know that if I go square root of a times the square root of a, that's the same thing as saying the square root of a squared, which I also know is a to the power 1. So it looks like if these are both the same, and these are both the same, because I could also think of this as a to the 1/2. Another way to think about this, here, I'll show you another way to think about it, is I could also, as opposed to doing 1/2 plus 1/2, I could also consider this a to the 1/2 to the power 2. Use my properties, I multiply those, that's a to the power 1. And so, if these are both a to the power 1, and if I square the same thing, it must mean that a to the 1/2 is equal to the square root of a. Okay, let's try it with a cubed. Well, this is the same thing as saying a to the 1/3 to the power 3, which is a. Or I could go a to the 1/3 plus 1/3 plus 1/3, which is also a. So this is the cube root of a cubed. And I know that is also a to the power 1. And so again, it seems like the cube root of a is the same as a to the 1/3. So that 1/3 is equal to the cube root of a. And so if I want to generalize it, if I have a fraction in my exponent, it's the same thing as having the nth root, because it could be any number here, of a. So if I had a to the 1/7, that's equal to the 7th root of a. Okay? And sometimes, if you're on your calculator, this is easier to put in your calculator than this one is. Okay, so let's look at the next scenario. So if I want to simplify this, well, I know that's the cube root of 8. And so that's saying what number times itself 3 times, the same number, 3 times, is equal to 8. Well, I know it's 2 times 2 times 2, so that is going to be 2. And some of these you just have to memorize. So similarly, if I look at this one, well, I know that I could say this is 8 to the 1/3 to the power of 4, which is also the cube root of 8 to the power of 4. Well, that I know is 2. I just did it to the power of 4. So 2 times 2 times 2 times 2 times 2 is 16. And so there's different ways to go about doing it. And so if I want to generalize this, I know the n is the root part, the a is here, and I can put this here. Or I could also, I didn't show you this, but sometimes it's easier, depending upon the numbers, to put the square here first, the m here, and then n in that order. So either this is equal to both of those to generalize. So another example, I want to write as a single power of 2. Well, it's just practicing rearranging these. Well, I know a cube root is the same as 2 to the 1/3. If I look at this, well, I know this is 1 over 2. Well, that's 1/2 on the bottom of my fraction. But if I know if I bring it to the top, I change the positive to a negative. This just means it switches position. And then finally I want a single power of 2, and this is a 4. Well, if I know the 5 becomes 4 to the 1/5, this is not a power 2, but it's a special number in terms of 2. It's 2 squared to the 1/5. So then I get 2 to the 2/5 is written as a single power of 2. And now we're going to evaluate without a GDC these ones. And so I know that this is the same thing as saying the cube root of 27 to the power of 4. But I don't know 27 to the power of 4. It's also the same as the cube root of 27 all to the power of 4. The cube root of 27, well, 3 times 3 times 3 I know is 27, so it's 3 to the power 4. This I know is 3 squared times 3 squared, because I add them, which is 9 times 9, which is 81. No calculator, just mental math. Similarly, if I do this one, the negative part means it goes onto the bottom of the fraction, to the 2/3. And I also know that the third is the cube root of 8, and I'm going to put the 2 on the outside. And so now I have 1, the cube root of 8 is 2 to the power of 2, and this is 1 over 1/4. Okay, so now, using our GDC, I'm going to show you a couple ways that we can do this. I want the cube root of 7. Well, I know that's the same as 7 to the 1/3. So one way I could do it is I could just go, if I go 7 to the power of 1 divide 3, it's all in the exponent, and I get 1.91. I could also, I know it's just cube root of 7, right? So I could just go to my calculator. I could go under the math button. If I show you the math buttons, I hit math, and if I look at number 4 here, that's the cube root of 7, and I will get the same thing. All right. When I do B part here, I want the 5th root. Well, I think the easiest way to do is 10 to the 1/5. So if I go 10 to the power of 1 divide 5, well, that's going to be 1.584. But I could also do this 5th root thing. In order to do that, if I look at my math here, this little x means I can put a number in there. In order to do that number, I start at my home screen here, and I'm going to put the 5 in first, and then I'm going to go to math, and this 5th one down, number 5. And it puts that 5 into that little x spot, and if I go 10, it ends up being the same value as 10 to the 1/5. So good use of calculator. This is expected, you know how to do that. Important rules for our exponents. We know that fractions are like roots. The bottom of the fraction is like the root.